Welcome back. This will be our second video from unit number 3. The last thing we looked at on the first video was the notion of a chain discount, and we actually took the time to find the individual discount amount reflected for each of those trade discounts in the chain. As we begin our second video from unit 3, we're gonna morph the solution process a bit, and we're going to introduce that notion of complement that we met previously, where if you're saving 20%, you're still paying 80%. You're paying the balance up to 100%. So let me open this thing up and let's share the PowerPoint and let's proceed. So if we decide that we could find a new way, that's in effect what we're going to do. We're going to find the effective one single shot discount play if you've got that chain at 20, 15, 10. Your author calls this a net equivalency rate. The detailed process is to take in each of the individual rates, find its complement, all right, relative to 100%, multiply all those decimal players together. Now, the important part here is, even if that turns out to be a pretty ugly multi-digit decimal beastie, don't round it. Keep it as exact as you can keep it, and then that will be used to calculate your subsequent information about net price relative to what the original list price was. Let's take a look at an example. We got Elmo's Electronics, going to buy $30,000 of electronics gear, and he's able to snag a 3-chain trade discount at 20, 10, and 5. All right, so let's go. We're going to find complements initially. You guessed it. If it's 20% off, we're still paying the other 80%. So as a decimal, that'll be 0.80. That second is a 10% discount. You guessed it. We're not paying 10, we're still paying 90. So there's 0.90 reflecting 90%. The last one at 5%, we're not paying 5, we're still paying the other 95, 0.95%. So a single shot look would be to multiply all those 3 decimals together, and we're finding the equivalent discount rate, or we're finding the equivalent rate that we're actually paying in this particular context. And there you can see the set to multiply. A little messy, 0.684. Again, don't round it, keep it intact. So if you were going to look at this and say, hey, I want to know what my net price is for this particular chain, what we can now do is use that 0.684, and we can find our net price in a one-shot deal by taking the $30,000 list price and simply multiplying by 0.684, and you guessed it, that gets us our net price. So we would be netting out at $20,520 if we were able to take that chain discount at 20, 10, and 5. Could have done this problem the way we ended video number 1. I personally think this is a little quicker, maybe a little cleaner. So I tend to like the notion of this one-shot equivalent rate. Okay, so if you wanted to just wrap that one up, that's what we found, 20,520 for our net price. If somebody says, hey, I want to know how much I actually saved, it's not hard. It's a subtraction problem, and you're there. You knew what the original list was, and now you know what your net is. So if you really had to have the number for trade discount, it's a subtraction, and you're there at $9,480. Okay. If you want to play just percentage notions, you notice that in effect we paid 68.4% of what we were able to once upon a time have as a list price if we were able to take all 3 of those chain discounts. If you say, well, gee, I really wonder how much that was as a one-shot discount rate. And again, it's that's the notion of complement one more time. Well, if we're paying 68.4%, we saved the difference relative to 100%. Now, the 100% in this arithmetic is showing as a 1, and you and I would realize that in this case, we would have saved as a single shot trade discount 31.6%. Okay? And just as a quick check, that gets us the exact same value we had previously. So in this context, our trade discount amount would have amounted to 31.6% on the one-shot deal. All right, let's play a different one. And in this case, what you now know is you know the net price and you know the trade discount, and you're curious, what was the list price for Gabby's Guppies? All right, so here's what you've done. You said, well, hey, if we're saving 20%, we're still paying 80%. So that complement idea is back for us. And now this takes us back to what we saw in a previous unit with percentages, where you've got percentage, base, and rate. In this context, list price plays the role of base. And what we know is that we have a 6,200 that represents a percentage of that base, and the specific percentage is that 80% that you see staring at you from the screen. Welcome to Algebra with Del. We're just going to divide both sides by 0.80, grab a calculator, and nobody get hurt. We got $7,750. So I like this in that it involves some of the ideas that we're just introducing. It brings back some of the things we looked at in previous units. And you should see that in math, that tends to happen a lot. Things cycle and stack upon one another. So that's not too bad. I like the way that plays. Here's number 8, where we've got that same kind of an idea where once again, we're trying to find out what was the list price. This time we've got that chain discount idea at 25, 20, and 10. Here comes some ideas of complements. You shouldn't be shocked. For the 25%, for the 20%, and for the 10%, you know what we're going to do. We're going to multiply those babies together. So if we do it 0.54, we caught a break here. We don't have a lot of ugly digits, but that's nice. So in effect, what we're paying is 54% of what the original list price was. So once again, we can go back and find it with that percent, base, and rate. Once again, your unknown would be the base. So you and I are going to put in the 12.5 as the percentage, solve for B using the 0.54 as our percentage, as our rate. All right, again, a quick divide, grab a calculator, and you find that without a whole lot of muss and fuss, the original list price was $23,148.15. So it's a nice application. Chain discounts work really well with this complement idea. The other thing that we'll look at to wrap up our second video here is sometimes you get a second trade discount that's a mystery so that you basically can compete with somebody who's got a lower price than you were able to get. And what your author proposes is that we represent that unknown rate as just D. Again, any letter would work. So as you and I approach the example 9, you know you got a first trade discount at 15%. But man, you got to match the competitor down the street who's beating you, and he's got a lower price at $250. So you're going to be able to maybe navigate a second trade discount. The question for us is, how much would it be? Okay, so here's your first discount. Again, complement idea. If you're not paying 15, you're paying the other 85. Be a little careful on this mystery guy. All right, so we're calling that mystery percentage just D. So when you and I write that in terms of what we've done for complement, it's 100% minus D%. Well, we're representing 100% here as 1. So we're just going to leave that as 1 minus D as we work forward. So the same thing we did previously to get that net equivalency, the one-time deal, we're going to multiply them together. So 0.85 times 1 minus D. And you might look at that and say, I'm going to distribute that. You certainly could. As you're going to see in a minute, I chose not to. All right, so that's my single equivalency rate. That will play the role for R for us as we come back and do our formula attack, where we're going to compare percentage, base, and rate. Now, in this context, the percentage we need to get is 250. So P is going to be 250. The base is what your original list price was. It was 350. Okay, and a little messy here going in for R is the 0.85 times 1 minus D. And you look at it and say, man, that's a lot. I can distribute. Yes, you can. I chose not to. What I'm going to show you on the screen next is what happens if you multiply 350 times 0.85. That's how the 297.5 got in. I want to do, no, just chill. Don't distribute yet. Let's go ahead and divide the 297.5. So maybe it's a different approach than what you would have looked at. If that's the case, cool. I thought it might be a little easier, a little less ugly numbers. So I'm going to go ahead and do that divide, and that's going to get me 0.84, la-di-da, la-di-da, la-di-da. Now notice I still have to solve for D. All right, so I still have algebra to do. So I'm going to subtract 1 from both sides, then I have to contend with some negatives. Don't get scared. I'm going to get 0.15, 15966. So that second trade discount that I had to be able to get to be able to match the 250 competitor price had to turn out to be 15.97%. It's similar to what we looked at where everything was known. That second now is a mystery. Call it D. The process behaves very similar to what you saw in example 8. That ends video 2. Thanks for playing. I'll be back soon with video 3 for unit 3.